Welcome. Today we will talk about capacitance and dielectrics. Also has to do with electric field and the radius of a sphere. The question or the problem is something like a spherical capacitor holds a charge of 3.3 nanocoulombs when connected or linked to a potential difference of 220 volts. The capacitor's plates are separated by a vacuum and the inner radius of the outer shell measures 4 cm. Determine letter A, the capacitance, B, the radius of the inner sphere, let us see the electric field immediately outside the surface of the inner sphere. Let us consider all our given and the required things, or the things that we need to know. What we know is 3.3 nanocoulombs, or 3.3 times 10 raised to your negative 9 coulombs. Your V is 220 volts. And you also had a 4 cm radius of the outer shell, so that's the inner radius of the outer shell, so that is your R, which is 4 cm. Right, now to get the capacitance, we ought to look for the capacitance. For the radius, according to our problem, it's the radius of the inner sphere. So this is the outer sphere that we have right now, out. So we need to look for the inner sphere, and also the electric field immediately outside electric field. So to get the capacitance, we have our Q, we have our V. Let's make use of our formula, which is C is equal to Q over V. C is equal to Q over V. Our Q is 3.3 times 10 raised to negative 9, all over 220 volts. The answer would be 1.5 negative 11 times 10 raised to negative 11 coulombs, if it's coulombs. All right, and the next is your R, radius inner. To get the inner radius, we've got to know how do we deal with the capacitance if we've got spherical coordinates. We can have 1 over RA minus 1 over RA minus 1 over RB, quantity of that, equals 4 pi epsilon naught over C. Now we've got a given C right over there. What we don't have is your Rin, and the Rin is basically a RA because we usually start our naming from the inside to the outside. So RA is what we're missing. We'll get here 7.4 per meter. Right, or 7.4 per meter. Right, and then we can distribute negative 1 over RB in this case. So we're done here. We're now working on Rin, which is your RA rather, excuse me. So 1 over RA I still need to get my RA by having the reciprocal of that. RA is equal to 1 over 32.4, which is 3. Yeah. Okay, which is our 3 cm here. There you go. 3 cm. For letter C, that is the electric field. It says here, we've got to determine the electric field immediately outside the surface of the inner sphere. For letter C, we remember that according to Gauss's law, electric flux is equal to EA. Also, electric flux is equal to your Q divided by epsilon naught. Equating the two, I can get EA equals Q divided by epsilon naught. And we'll look into our E. So to get the E for that, we also remember that to get the E, we've got to have K Q over R squared. Whatever the corresponding K, whatever the corresponding R in this case. Now, since we have K Q over R squared, we can definitely go for letter E. K is 9 times 10 raised to 9 here. Your Q is this one, 3.3 negative 9. There you go. Divided by your R squared, which is its inner, so 3 cm, 0.03 squared. 0.03 squared. Now this will be 3.3 times 10 raised to 4 newtons. Is it newtons? You have to remember the unit for your electric field.